Hello, mathematician. In this video, we explore solving a linear quadratic system algebraically. We're going to use the elimination method. Here we have a system of equations. 5x minus 10 equals y, and x squared plus x minus 2y is equal to 0. In order to solve the system algebraically using the elimination method, our first step is to align the like terms. The like terms have the same variable to the same degree, so it's going to be to our advantage to put all the variable terms on one side of the equation and all the constant terms on the other. So let's put all of our variable terms on the left side of the equation. So in our first equation, we've got 5x minus 10 equals y. We're going to have our variables on the left and our constants on the right, which means we're going to subtract y from both sides, which will give us 5x minus y minus 10 is equal to 0. And then, mathematician, we're going to move the constant over to the right-hand side. So we're going to add 10 to both sides. We move terms from one side of the equation to the other using our inverse operations. When we do that, we would have 5x minus y is equal to 0. And now in that second equation, we'll notice that we will be able to write that pretty easily with our like terms lined up. X squared plus x minus 2y now is equal to 0. Our like terms are aligned. The first step is already done. The next step is to make the coefficient of the y terms have the same magnitude and opposite signs using multiplication if needed. We'll notice that our y terms, for the first y term, the coefficient is -1, and the second y term, the coefficient is -2. They have different coefficients, and the magnitudes are different. The magnitude of -1 is just 1, and the magnitude of -2 is just 2. Remember that magnitude simply means the value, how far the value is from 0, regardless of the sign. So -1 is 1 unit away from 0, and -2 is 2 units away from 0. So that would mean that their magnitudes are different. Now, in order to force the magnitudes to be the same, we're going to multiply that first equation. The lowest common multiple between 1 and 2 is 2. So we're going to multiply that first equation by, we would multiply it by 2, except that would make the magnitudes the same. If we distributed the 2 to each term, that would give us a 10x minus 2y equals 0. So the magnitudes would be the same. However, the signs would still be the same. So we want to make it an opposite sign. So instead of multiplying by a +2, mathematician will multiply by a -2. So we multiply by a -2. Now we'll have the first equation will become -10x plus 2y equals 0. And then we'll have x squared plus x minus 2y equaling 0. And you may notice something already happening here, mathematician. When we do that, we are now, our y terms have the coefficients of the y terms have the same magnitude, but have opposite signs, which is really great for us. So the second step is accomplished. The next step that we want to do is to combine the columns of like terms. When we combine the columns of like terms, we don't have an x squared term in the linear equation, the first equation. So that'd be like 0 plus x squared. So that would give us just x squared. And then we'll have -10x plus 1x, which would be -9x. And then look at that, we get to eliminate our y terms because their coefficients have the same magnitude but opposite signs. So that will be 0, that'll be nothing. And then that's going to equal 0 plus 0, which is 0. Now, we have the equation x squared minus 9x. So we have x squared minus 9x equals 0. And we have already accomplished our third step, which means our fourth step is to solve the resulting equation for x. Here we have a quadratic equation. We have some options on how to solve it. we could either use our quadratic formula or we could solve by factoring. This one should be pretty easy to solve by factoring, as we actually do have a GCF, which is going to be x. We'll factor the x out, and we'll have x minus 9 equals 0. And with that, we now have a factored expression, and it's factored completely. And now all we have to do is use our zero factor theorem in order to find the values of x that would make this equation true. So we can set each factor equal to 0, because this factor will equal each factor with a variable. So each factor with a variable equals to 0. So that means x will equal 0, or x minus 9 will equal 0. So that means that one value that would make this equation true would be if x were 0. 0 times anything would give you 0. Now the other value would be what you get when you isolate for x in that second equation. And we'll have x is equal to 9. Now, we know the values that make this equation true are when x is equal to 0, or when x is equal to 9. Now, we solved for x. So, mathematician, the fourth step is already accomplished. The fifth step is to substitute x into one of the original equations and solve for the corresponding values of y. So, we go back into one of the original equations, and we'll notice that one of the equations is a little bit easier to work with than the other. Like, for example, we have this linear equation, but it's easier to work with than the quadratic because we don't even have to square anything at any point. So we'll just use that second equation. We'll write it as y is equal to 5x minus 10. So we'll have, we'll know that y is equal to 5x minus 10. What that means is that y1, which will correspond to x1, so y1 will equal 5x, 5 times x1 minus 10, which will equal 5 times 0 minus 10. So 5 times 0 is going to be 0, minus 10 is going to be negative 10. So our y1 is negative 10. Now for the second value of y that should correspond to the second value of x, we'll call that y2. And that will equal 5 times x2 minus 10, equaling 5 times 9 minus 10. 5 times 9 is 45. Minus 10 will be 35. And with that, mathematician, we can write, we can notice that we actually have already done the substitution. We substituted x into the original equation in order to solve for the corresponding value of y. So the fifth step is already done. Now, the sixth step is to state your final answer as an ordered pair. So we have a couple of ordered pairs. We've got our x1 comma y1, and we've got our x2 comma y2. So our ordered pairs, our solution ordered pairs, are going to be 0, that's x1, and y1, we calculated that at negative 10. And the other ordered pair that is a solution to the system is going to be 9 for the x2 and 35. And with that, mathematician, we have solved a linear quadratic system algebraically using the elimination method. Now, if that process seemed pretty easy for you and you'd like to see more pretty easy solutions of how to handle these algebraic calculations, then you can check out our resources in the show notes below.